Hello everyone, here is an interesting problem on the board. It is known as the Galileo's kinematical paradox. If you wish, you may pause the video here and think about the answer yourself. The situation is simple. The entire system is in vertical plane and we release 5 beads simultaneously from the top of the ring. Which bead will reach to the bottom first? Give it a try. I hope you are done with your calculations and the correct answer is all the beads reach the bottom at the same time. We can prove it very easily. Let us focus on the vertical diameter of the circle. This distance we take as d. The acceleration due to gravity is g. Okay. A bead starts from here. T is equal to 0, u is equal to 0 for this bead. We can use the second equation of motion, s is equal to ut plus half at square. For doing the calculations, we are taking this direction positive for this bead. Its displacement till it reaches here the bottom is taken as d. U is 0, so this part vanishes, half, and acceleration is g multiplied with t square. So t comes out to be root of 2d by g. Simple computation. Okay. Now let us focus on this path. A bead starts here at t is equal to 0. Its initial velocity is 0 and that bead reaches here at the bottom of this path. For doing the calculation, I am taking up this angle as theta. Then component of g in this direction will be actually equal to g cos theta. Okay. Actually, we can complete the triangle here, and it's the property of the circle that if you consider this diameter and these two chords of the circle, then angle here is 90 degree. Okay. So this is the largest side of this right angle triangle. Now we can eventually find this red distance also in the terms of d and theta. This red distance will be actually equal to d cos theta. Check it. D cos theta. Okay. Now for doing the calculation for the red bead, I am choosing this direction to be positive. And again using the second equation of motion. So that calculation is done here. The displacement of the bead along this direction is d cos theta, put up that here, is equal to u part is 0, initial velocity is 0, so leave that, and acceleration is g cos theta, so half g cos theta into t square. T comes out to be root 2d by g. An interesting insight. The theta is of no matter in this entire calculation. So you choose this path, you choose this path, or the paths like these. The beads will reach the bottom at the same time, root 2d by g. Getting it? There is some insight in this calculation. If we look at this vertical diameter, here distance traveled is d and the acceleration is g. Comparatively, if we look at the red path, the distance is d cos theta, but the acceleration is also g cos theta. The distance and the acceleration, they are getting reduced by the same factor. So the time taken will come out to be same. Getting it? This is an interesting question. If you wish, you may note down all these information. Here is an interesting consequence of the previous problem. The position of all these beads at an instant will be lying on an expanding circle, and the center of circle will be accelerating down at a rate g by 2. This is pretty important. I request you to pause the video here, note down the statement and the diagram, because on the next screen I'll fill up the entire board with the derivation and I'll prove that center of these expanding circles will be accelerating down. Okay, note it down. I am moving forward for the derivation. Let's draw the diagram here again. Suppose we choose this as the x-axis and we consider here the y-axis. Origin of the coordinate system is taken here as 0, 0. The bead goes over this path. The bead starts from here. So at t is equal to 0, for the bead, the initial velocity is 0. The acceleration due to gravity is acting toward the center of Earth. If we imagine this angle to be theta, then the component of acceleration due to gravity in this direction will be g cos theta, because this angle is also theta. After some time t, the bead reaches here and we are trying to write its x and y coordinates. So let's say this indicates the x coordinate, this indicates the y, and the bead has traveled here some distance which we write as s. How we can find that s? Using the second equation of motion. S is equal to ut plus half at square. Okay, u is 0, so s comes out to be half g cos theta, because acceleration along this direction is g cos theta multiplied with the t square. Okay, now using the s and theta, we can find the x coordinate as well as y coordinate. I am going to write the data here. The x coordinate will be equal to what? S sine theta. Do you agree? Check it once. S sine theta is the x coordinate. And what about the y? The y coordinate can be written as s cos theta. Value of s we can submit from here. So I am doing that computation. G by 2 t square cos theta. This is the value of s. And here was sine theta. Here also I am submitting the value of s, g by 2 t square cos theta, and another cos theta was already present. Here we can see cos theta sine theta. Do you remember any formula from trigonometry for cos theta sine theta? Correct. This cos theta sine theta can be replaced as sine 2 theta by 2, and here was lying gt square by 2. Okay, similarly here we have cos square theta. At the place of cos square theta from trigonometry, what we can put? Correct, 1 plus cos 2 theta by 2. All these things are taught already in the video of the trigonometry. You can go and check that playlist if you don't remember the formulas. So this expression of the y will be represented as g by 2 t square, and the replacement here is 1 plus cos 2 theta by 2. Simple computation. So here I'll get the final value of x is equal to gt square by 4 sine 2 theta, and the final value of y here is gt square by 4 plus gt square by 4 cos 2 theta. Do you agree? This gt square by 4 I am shifting in the LHS. Y minus gt square by 4 is equal to gt square by 4 cos 2 theta. We are calling it equation number 2, and we are calling it equation number 1. Pay attention to the things. The RHS of the equation number 1 has the term sine 2 theta, and the RHS of the equation number 2 has the term cos 2 theta. Do you get any trigonometric operation in your mind? What we should do? Correct. I am going to square and add these two equations. So in LHS, what we should be writing? X square plus y minus gt square by 4 whole square is equal to gt square by 4 whole square. This sine square 2 theta plus cos square 2 theta we know will become 1. Okay, so no need of writing that. Look at this beautiful expression. This expression reminds you of the equation of a circle, and even this x we can rewrite as x minus 0 whole square. Now you can compare it easily. X minus a whole square plus y minus b whole square is equal to r square. So this is the equation of circle. Now the center of these expanding circles will be moving only on the y-axis, because the x coordinate for that center is coming out to be 0. Understand that important thing. The center of expanding circles moving only along this y-axis. That is the first important information. Second important information, if we check the standard format, then this data inside the bracket gives us the radius r. I am writing that here. R is equal to 1 by 2 gt square by 2, like this. This data inside the bracket I am rewriting in this manner. How the circles are formed? Suppose initially the position of these beads is lying over this circle. After some moment of time, the position of all the beads will be lying over this circle. Then after some other moment of time, the position of all these beads will be lying over this circle. So these circles will keep on expanding. Suppose at some moment the center of the circle is here, and up to here the distance we consider as r. So this r is actually continuously increasing. If you need the velocity of the center, then what you should do? d by dt of r. Here g by 4 was a constant, so I took it outside. We are left with d by dt of t square only. Okay, so the final result is g by 2 multiplied with t. Is it okay? Now the acceleration of that center can easily be obtained. d by dt of the velocity will give us the acceleration of the center. G by 2 is a constant, we'll take it outside and we'll differentiate t. Differentiation of t with respect to t will give you 1. So final computation will be giving us the acceleration of the center as g by 2. This acceleration is constant, and we have proved it. Getting it? It's the beautiful calculation. So if you wish, you may pause here, you may note down the things, you may try all these calculations yourself. If you understand these calculations very well, then only you can answer the question which I am going to give you on the next screen. I hope you are enjoying the learning. Note it down. Here is the last question of this video. If you wish, again you may pause and give it a try. I hope you got the correct answer this time. All the beads will reach the bottom again at the same time. Calculation is pretty simple. Since beads are small, so there is no air resistance considered, and it's given in the question they are sliding down without any friction. Okay, I'm doing the calculation here. As we remember the previous question, along the vertical diameter, this bead will take up how much time? We know that t is equal to root 2d by g if this distance is d. Okay, so I'm doing computation for this path. Let's say a bead starts here, t is equal to 0, u is equal to 0, and we consider this angle to be theta. Okay, I'm completing the triangle here. We already know that this angle is 90 degree. If this angle is theta, this should be theta. This should be 90 degree minus theta. Do you agree? And then I'm extending this line. This angle will also be 90 degree minus theta. Now acceleration due to gravity is vertically downward like this, g. G will have a component in this direction. How much is that component? G sine theta. And the component of G along the red direction will be G cos theta. For calculation purpose, we are using this component of acceleration due to gravity. I am doing the calculation for the red bead using the second equation of motion, S is equal to ut plus half at square. Okay, u is 0, so this part vanishes. The S, we need this distance. It's pretty easy. If this is d, then this red distance you can compute will come out to be d cos theta in this triangle. Give it a try. Is equal to half. The acceleration is g cos theta along this path and then t square. Cos theta is again getting cancelled out. T comes out to be root 2d by g. Again the same time taken. So if these two beads are released at t is equal to 0, they will reach the bottom at the same moment of time. Similarly, you can prove for this bead also. That computation I am leaving to you. You can do your calculation and check it out. The time will again come out to be root 2d by g. Getting it? These are beautiful questions. I hope you enjoyed the video. Stay awesome. Take care. Happy learning.